I'm going to actually save the floating example for next class when you do the boat lab, because that's when you're going to actually do practice with floating. And so I'll save that example for then. So let's just do the buoyant force example when we're doing something that's submerged in water. So a 550 gram aluminum cube, which has a density of 2.7 times 10 to the third, requires a force of 5.4 newtons to support it when suspended in the air. What force does it need when it's suspended in the water? So step one is you're going to draw a free body diagram for the object, and you're going to set up Newton's second law. So we have an aluminum cube that's supported by something. So I'm going to go ahead and draw it when it's in water, but it gives you kind of both examples, and it's supported by something. So that means there's actually three forces acting here. There is the support force, or the tension, or the lift, or whatever you want to call it. But then there's also the buoyant force, because it's submerged in water. And that's true for the air. There's a buoyant force in the air too. It's just very tiny. And then there's some downward force of gravity. So there's my forces. Buoyant force up, tension up, but for whatever the support force is, you can call it normal. It doesn't matter. There's some upward force in addition to buoyant force, and then gravity down. Then we're going to set up Newton's law. So Newton's second law is F net equals ma. So the net force is all the up forces minus all the down forces. So buoyant up plus tension up minus gravity down equals ma, which is going to be 0 unless it tells me there's an acceleration. It does not tell me there's an acceleration, so I can assume it's 0. So there we go. Step 1, done. Step 2, find the buoyant force using the weight of the fluid. Hint number 1, remember the two key ideas from number 1. And hint number 2, you will need to use your density equation to help you jump between volume and mass. So we talked about support force on an object in a fluid, so it's the pressure difference. What we're looking at here is basically we're trying to solve these. So we need to figure out what the buoyant force is to figure out the tension. I can figure out gravity easy enough, so Fg equals mg. So this is a 550 gram cube. It needs to be in kilograms, so it's 0.550 kilograms times g, which is 9.8 meters per second squared. So that's easy enough to figure out what that value is. I'll go ahead and do that now. 0.55 times 9.8 gives me force of gravity 5.39 newtons. But I need to find the buoyant force somewhere. So the equations we had for buoyant force were these. Mass of the fluid times gravity, so weight of the fluid. Well, I don't know the mass of the displaced fluid, because it's not the mass of the total fluid, it's the mass of the fluid that's pushed out of the way. I don't know what that is. But I do know how these things relate together with mass and density. So that's what I'm going to do, because essentially this equation comes from this with volume substituted in instead of mass, because instead of using mass, we're doing density. Mass is density times volume. So we change it around a little bit, and we can use this equation. So that's what I'm going to do here to find the buoyant force. You won't be able to use this every time. Sometimes you'll have to use this equation to solve for buoyant force first. But I usually try to give you hints on that if I can, at least early on here. So the equation we're using is the buoyant force is equal to the density of the fluid times the mass of the object divided by the density of the object times g. Okay? So, density of the fluid is water. 1 times 10 to the third, which is 1,000. So if you want to go ahead and write it out as 1,000, that's what I usually do here. Then it's the mass of the object. It's a 550 gram aluminum cube, so that's 0.550 divided by the density of the object. 2.7 times 10 to the third is 2,700 times g, which is 9.8. So 1,000 times 0.550 divided by 2700 times 9.8 gives me a buoyant force of 2.00 newtons. And so now use Newton's third law to find the amount of force needed to lift the mass. So here's my Newton's second law. Buoyant force is 2.00 plus the tension force, which we don't know, minus gravity, which is 5.39, equals 0. Solve the numbers around. And you get a tension force of 3.39 newtons. And if you got a slightly different number, it's probably a rounding thing. Okay, so that's how you're going to go ahead and solve these problems. Go ahead and work on practice 2. So number 1 is very similar. You have a rock that's placed on a scale. So instead of there being a tension force, there's a normal force from the scale pushing up, plus a buoyant force, plus gravity. Okay? This other one here on the back is very similar to the one we just did. Notice it does not say anything about acceleration, so assume the acceleration is 0. But this one does have a lifting force. Okay? So try those and see what you can do. That's your homework for next time. Also, practice 1 should be done, so make sure you finish that one as well. All right, y'all. Have a blessed day. Work hard. We're almost there. Next time you get to build little mini paper boats. Get excited.